In this video, we shall have a basic introduction to integration, and then after that, we shall look at the rules of integration. Let's say we have the integral of x to the power of n dx. Now, whenever you have such an integral, all you have to do is raise the power of the function by 1 and then divide by the new power. In this case, the power is n. If you raise n by 1, you get n plus 1. So, the integral of x to the power of n will be equal to x to the power of n plus 1, and then divided by the new power, which is n plus 1. And then we have to add the constant of integration, c. Now, there is one thing you have to note. Integration is the opposite of differentiation. Let's say you had the derivative of x to the power of n. This will be equal to n times x to the power of n minus 1. Now, since integration is the opposite of differentiation, if you integrate this, you should go back to this. Let's prove that. So we shall have the integral of n times x to the power of n minus 1 dx. And since n is a constant, we can pull it out. So we shall have n times the integral of x to the power of n minus 1 dx. Now at this point, we shall raise the power of the function by 1 and then divide by the new power. So we shall have n times, this will be x to the power of n minus 1 plus 1 divided by the new power, which is n minus 1 plus 1, and then plus c. This will cancel with that, and also this will cancel with that. And so we shall have n times x to the power of n divided by n. This will cancel with that. And so we shall have x to the power of n and then plus c, hence proved. So you go back to this. And this is called the power rule. So let's look at some examples where we apply the power rule. Let's say we have the integral of 3 times dx. Now to solve this, first of all, we can write it as the integral of 3 times x to the power of 0 dx. This is because any number raised to the power of 0 is 1. So 3x to the power of 0 is the same as 3 times 1, which is 3. And since 3 is a constant, we can pull it out. So we shall have 3 times the integral of x to the power of 0 dx. And at this point, we can use the power rule. So we raise the power of the function by 1 and then divide by the new power. So we shall have 3 times x to the power of 0 plus 1 divided by 0 plus 1 and then plus c. And this will be equal to 3 into x to the power of 1 divided by 1 plus c, which is equal to 3x plus c. And that's our answer. You try out this. Solve the integral of 5 times dx. Now once again, this is the same as the integral of 5 times x to the power of 0 dx. And if we take out 5, we shall have 5 times the integral of x to the power of 0 dx. And at this point, we can integrate. So we shall have 5 times x to the power of 0 plus 1 divided by 0 plus 1 and then plus c, which will be equal to 5x plus c. So whenever you are integrating a constant, you just add a variable. In this case, we are integrating 5 with respect to x. So we add x and we get 5x. Now you try this. Let's say you have the integral of negative 9 times dy. In this case, you are integrating with respect to y. So this will be equal to negative 9y plus c. Now you solve the integral of 10x plus 2 times dx. Now this can be written as the integral of 10x to the power of 1 plus 2 times x to the power of 0 dx. And at this point, we can integrate. So we shall have 10 times x to the power of 1 plus 1 divided by the new power, which is 1 plus 1, and then plus 2 times x to the power of 0 plus 1 divided by 0 plus 1, and then plus c. And this will be equal to 10 times x to the power of 2 divided by 2 plus 2 times x to the power of 1 divided by 1 plus c, which is equal to, now 10 divided by 2 will be 5. So this will be 5x to the power of 2, and then plus 2x plus c. And if you want, you can pull out x because it is a common factor. So this will be equal to x into, for the first part we shall remain with 5x, and then for the second part we shall remain with 2 plus c. Now let's say we had the integral of 3x minus 4 dx. Now one thing you have to learn, if you want, you can split this. So this is the same as the integral of 3x times dx, and then plus the integral of negative 4 dx. And so this will be the integral of 3x dx plus, now negative 4 can be written as negative 4 times x to the power of 0, and then dx. And at this point we can take out the constants, and so we shall have 3 times the integral of x to the power of 1 dx. And then for the second integral, if we take out negative 4, we shall remain with x to the power of 0 dx. And at this point we can integrate, so we shall have 3 times x to the power of 1 plus 1 divided by 1 plus 1 minus 4 times x to the power of 0 plus 1 divided by 0 plus 1, and then plus c. So this will be equal to 3x to the power of 2 divided by 2 minus 4 times x, and then plus c. And if we pull out x, we shall have x into 3x divided by 2 minus 4, and then plus c. And that's our answer. Now that you know what to do, you try out this. Solve the integral of 3x to the power of 2 plus 2x minus 1 times dx. If we integrate this, we shall have 3 times x to the power, now 2 plus 1 will be 3, divided by 3, and then plus 2 times x to the power of 2 divided by 2, because x has a power of 1. And then negative 1 will become negative x plus c. Now this 3 will cancel with that, and then this 2 will cancel with that. And so we shall have x to the power of 3 plus x to the power of 2 minus x plus c. And to simplify this, let's pull out x. So we shall have x into x to the power of 2 plus x minus 1, and then plus c. Now you try this. Solve the integral of x minus 1 times 2x plus 3 dx. Now to solve this, the first thing you need to do is expand. So this will be the integral. X times 2x will give us 2x to the power of 2. So this will be 2x to the power of 2. And then we shall get this times this, and that will give us plus 3x. And then this times this, which will give us negative 2x. And lastly, negative 1 times 3, which will give us negative 3 times dx. And so we shall have the integral of 2x to the power of 2. Now 3x minus 2x will be plus x, and then minus 3 times dx. And at this point we can integrate. So we shall have 2 times x to the power of 3 divided by 3, and then plus x to the power of 2 divided by 2, and then minus 3x plus c. And that's our answer. Now let's see how we can integrate functions with negative exponents. Let's say we have the integral of x to the power of negative 5 dx. Now once again we shall raise the power of the function by 1 and divide by the new power. So we shall have x to the power of negative 5 plus 1 divided by negative 5 plus 1, and then plus c. And this will be equal to x to the power, now negative 5 plus 1 is negative 4, divided by negative 4 plus c. Now from the rules of exponents, you can take this to the bottom, and the negative exponent will become positive. So this will be equal to 1 divided by negative 4 times x to the power of 4, and then plus c, which is the same as negative 1 divided by 4x to the power of 4 plus c. Now you try out this. Solve the integral of 1 divided by x to the power of 3 times dx. Once again, from the rules of exponents, we can take this to the top, and the positive exponent will become negative. So this is the same as the integral of x to the power of negative 3 dx. And if we integrate this, we shall have x to the power of negative 3 plus 1 divided by negative 3 plus 1 plus c. And this will be equal to x to the power of negative 2 divided by negative 2 plus c. And if we take this to the bottom, we shall have 1 divided by negative 2x to the power of 2 plus c. And that's our answer. Now let's see how we can integrate radical functions. Let's say we have the integral of the square root of x dx. Now for square roots, the exponent is 1 and the index is 2. So this is the same as the integral of x to the power of 1 over 2 dx, where 2 is the index and 1 is the exponent. And at this point we can integrate, so we shall have x to the power of 1 divided by 2 plus 1 divided by 1 divided by 2 plus 1 and then plus c. Now 1 divided by 2 plus 1 is the same as 1 divided by 2 and then plus 2 divided by 2. And since we have the same denominator, we can combine the numerators. So this will be 1 plus 2 divided by 2, which is equal to 3 divided by 2. So we shall replace this and this with 3 divided by 2. This will give us x to the power of 3 divided by 2 and then divided by 3 divided by 2 plus c. Now to simplify this, let's multiply this by 2 divided by 3 and also multiply this by 2 divided by 3. This will cancel with that and also this will cancel with that. And so we shall have 2 divided by 3 times x to the power of 3 divided by 2 and then divided by 1 plus c, which will be equal to 2 divided by 3 times x to the power of 3 over 2 and then plus c. And that's our answer. Now you solve this. In this case, the exponent is 5 and the index is 3. So this is the same as the integral of x to the power of 5 divided by 3 dx. And if we integrate this, we shall have x to the power of 5 over 3 plus 1 divided by 5 over 3 plus 1 and then plus c. And 5 over 3 plus 1 is the same as 5 divided by 3 plus 3 divided by 3, which is the same as 5 plus 3 divided by 3, which is 8 divided by 3. Therefore, this will be x to the power of 8 divided by 3 divided by 8 over 3 and then plus c. Now let's multiply this by 3 over 8 and also this by 3 over 8. This will cancel with that and also this 8 will cancel with that and we shall remain with 1. So this will be 3 divided by 8 times x to the power of 8 over 3 plus c, and that's our answer. Now let's see how we can integrate exponential functions. Whenever you have the integral of e to the power of u times du, this will be equal to e to the power of u divided by u prime and then plus c. In this case, u prime is the derivative of u. Let's say we have the integral of e to the power of x dx. In this case, u equals to x, and so u prime will be equal to, when you differentiate x, you get 1. So the integral of e to the power of x will be equal to e to the power of u is x, divided by u prime, which is 1, and then plus c, which is equal to e to the power of x plus c. Now you try this. Solve the integral of e to the power of negative 5x dx. In this case, u equals to negative 5x, and so u prime will be equal to, when you differentiate negative 5x, you get negative 5. So this will be equal to e to the power of negative 5x divided by u prime, which is negative 5, plus c. Let's look at another example. Let's solve the integral of e to the power of 8x dx. This will be equal to e to the power of 8x divided by the derivative of 8x, which is 8, plus c. Now let's see how we can integrate rational functions. Let's say we have the integral of 1 divided by x dx. What would be the answer to this integral? Now if the numerator is the derivative of the denominator, then the answer will be equal to natural log of the denominator. For this example, we know that when we differentiate x, we get 1. Therefore, the numerator is the derivative of the denominator. So this will be equal to natural log of x plus c. Now let's say we have the integral of 3 divided by x minus 7 times dx. Now this can also be written as 3 times the integral of 1 divided by x minus 7 dx. And we know that when you differentiate x, you get 1, and when you differentiate negative 7, you get 0. Therefore, the numerator is the derivative of the denominator. So this will be equal to 3 times the natural log of x minus 7 plus c. Okay, you try this. Solve the integral of 3x to the power of 2 plus 1 divided by x to the power of 3 plus x and then plus 5 dx. Now when you differentiate x to the power of 3, you get 3x to the power of 2. And when you differentiate x, you get 1. And if you differentiate 5, you get 0. And at the top, we have 3x to the power of 2 plus 1. Therefore, the numerator is the derivative of the denominator. So this will be equal to natural log of x to the power of 3 plus x plus 5 and then plus c. Now what if you had the integral of x divided by 1 minus x to the power of 2 times dx? When we differentiate 1, we get 0, and when we differentiate x to the power of 2, we get 2x. Therefore, the derivative of the denominator is negative 2x. But the numerator is x. So we need to make sure that at the top we have negative 2x. To do that, let's multiply this by negative 2 and then divide through by negative 2. So this will be equal to negative 1 divided by 2 times the integral of negative 2x divided by 1 minus x to the power of 2 dx. And at this point, the numerator is the derivative of the denominator. So the answer will be negative 1 divided by 2 times natural log of 1 minus x to the power of 2 plus c. And if you want, you can simplify this. From logarithms, we can take this to the top. So this will be equal to natural log of 1 minus x to the power of 2 raised to the power of negative 1 over 2 plus c, which is also the same as natural log of 1 divided by 1 minus x to the power of 2 raised to the power of 1 over 2 and then plus c, which can also be written as natural log of 1 divided by the square root of 1 minus x to the power of 2 plus c. Now let's look at the integration of trigonometric functions. Let's say we have the integral of cosine x dx. Now if you take the derivative of the sine of x, this will be equal to cosine x. And if you remember, we said that integration is the opposite of differentiation. So if you integrate cosine x, you should get sine x. Therefore, this will be equal to sine x plus c. Now what about the integral of sine x dx? We know that when we differentiate the cosine of x, we get negative sine x. Therefore, when you integrate this, you should get cosine x. But in our case, we have positive sine x. So what we shall do, we shall introduce a negative and then multiply the integral by negative 1 so that nothing is changed. And so this will be equal to negative. When we integrate negative sine x, we get cosine x plus c. Now let's say we had the integral of cosine 4x dx. How would you integrate this? We know that when we integrate cosine, we get sine. So we shall write sine 4x, and then we shall divide this by the derivative of the angle. Our angle is 4x. When you differentiate 4x, you get 4. So this will be divided by 4, and then plus c. Now what if you had the integral of sine 9x dx? We know that when we integrate sine, we get negative cosine. So we shall write negative cosine 9x, and then we shall divide this by the derivative of 9x, which is 9, plus c. Now you try this. Solve the integral of 9 times sine 3x dx. Now this can also be written as 9 times the integral of sine 3x dx. And if we integrate this, we shall have 9 times. Now when you integrate sine, you get negative cosine. So we shall write negative cosine 3x divided by the derivative of 3x, which is 3, and then plus c. Now this 3 will cancel with 9, and we shall remain with 3. And so this will be equal to negative 3 times cosine 3x plus c. Now what about the integral of secant squared x dx? If you take the derivative of tangent x, you get secant squared x. Therefore, if you integrate secant squared x, you should get tangent x. So this will be equal to tangent x plus c. Now you try out this. Solve the integral of 12 times secant squared 3x dx. Now this can also be written as 12 times the integral of secant squared 3x dx. And if we integrate this, we shall have 12 times. Now when you integrate secant squared x, you get tangent x. So this will be tangent 3x, and then we shall divide through by the derivative of 3x, which is 3, plus c. This 3 will cancel with 12, and we shall remain with 4. And so our final answer will be 4 tangent 3x plus c. Now what if you had the integral of secant x times tangent x dx? We know that if you differentiate secant x, you get secant x tangent x. Therefore, if you integrate secant x tangent x, you should get secant x. So this will be equal to secant x plus c. Now you try this. Solve the integral of 5 times secant to x times tangent to x dx. This can also be written as 5 times the integral of secant to x tangent to x dx. And if you integrate this, we shall have 5 times. When you integrate secant x tangent x, you get secant x. So we shall write secant to x and then divided by 2 plus c. So our final answer is 5 divided by 2 times secant to x plus c. Now there is also what we call U-substitution. Let's say we have the integral of 3x times e to the power of x squared dx. What should u be equal to? Let's say if we set u to be equal to 3x, the derivative of u, which is du, will be equal to, if you differentiate 3x, you get 3 times dx. And this 3 cannot cancel with 3x. Therefore, u cannot be equal to 3x. So what we need to do is set u to be equal to x to the power of 2. And so du will be equal to, if you differentiate x to the power of 2, you get 2x times dx. And as you can see, this x will be able to cancel with this x. So now let's find dx. If we divide both sides by 2x, This will cancel with that. And so dx will be equal to du divided by 2x. And so we shall replace dx with du divided by 2x. And then we shall replace x to the power of 2 with u. So this will be equal to the integral of 3x times e to the power. Now x to the power of 2 is u. And then times dx, which is du, divided by 2x. This x will cancel with that. And so we shall have the integral of 3 divided by 2 times e to the power of u du. Now if we pull out 3 divided by 2, we shall have 3 divided by 2 times the integral of e to the power of u du. And we know that the integral of e to the power of u is e to the power of u. So this will be 3 divided by 2 times e to the power of u plus c. And we know that u equals to x to the power of 2. So this will be equal to 3 divided by 2 times e to the power of x squared plus c. And that's our answer. Let's look at another example. Let's say we have the integral of 4x times x to the power of 2 plus 5 raised to the power of 3 times dx. How can we solve this using U-substitution? We need to set u to be equal to x to the power of 2 plus 5. Because in this case, du will be equal to 2x times dx. And this 2x will be able to cancel with this. So now let's find dx. We shall divide this by 2x and also this by 2x. This will cancel with that. And so dx will be equal to du divided by 2x. And so we shall replace this with du divided by 2x. And then replace x to the power of 2 plus 5 with u. So this will be equal to the integral of 4x times u raised to the power of 3 and then times dx, which is du divided by 2x. Now this 2x will cancel with 4x and we shall remain with 2. And so we shall have the integral of 2 times u to the power of 3 du. And if we take out 2, we shall have 2 times the integral of u to the power of 3 du. And at this point we can integrate. So we shall have 2 into, this will be u to the power of 4 divided by 4 plus c. Now this 2 will cancel with 4 and we shall remain with 2. So this will be equal to u to the power of 4 divided by 2 plus c. And we know that u equals to x to the power of 2 plus 5. So our final answer will be 1 divided by 2 times x to the power of 2 plus 5 raised to the power of 4 plus c. Now you try out this. Solve the integral of x to the power of 2 times the cosine of x to the power of 3 dx. Now in this case, we need to set u to be equal to x to the power of 3. Because if we do that, we shall have u equaling to x to the power of 3. And so du will be equal to the derivative of x to the power of 3, which is 3x to the power of 2 times dx. And therefore this x to the power of 2 will cancel with that. And to find dx, let's divide this by 3x to the power of 2 and also this by 3x to the power of 2. This will cancel with that. And so we shall have dx equaling to du divided by 3x to the power of 2. And so our integral will be the integral of x to the power of 2 times the cosine of x to the power of 3, which is u, and then times dx, which is du divided by 3x to the power of 2. Now this x to the power of 2 will cancel with that. And so we shall have the integral of 1 divided by 3 times cosine u du. And if we take out 1 divided by 3, we shall have 1 divided by 3 times the integral of cosine u du. And at this point we can integrate. So we shall have 1 divided by 3. Now when you integrate cosine u, you get sine u plus c. And if we put in u equals to x to the power of 3, we shall have 1 divided by 3 times the sine of x to the power of 3 plus c. And that's our answer. Now what if you were told to solve the integral of tangent x dx using U-substitution? This will be equal to the integral. Now tangent x is the same as sine x divided by cosine x and then times dx. And at this point we can let u to be equal to the cosine of x, and so du will be equal to, if you differentiate cosine x, you get negative sine x times dx. And if we divide this by negative sine x and also this by negative sine x, this will cancel with that, and so dx will be equal to negative du divided by sine x. So this will become the integral of sine x divided by cosine x, which is u, and then times dx, which is negative du divided by sine x. This will cancel with that, and if we take out the negative, we shall have minus integral of 1 divided by u times du. And if you remember, we said that the integral of 1 divided by x dx is equal to natural log of x. And so the integral of 1 divided by u will be natural log of u plus c. And at this point, we can replace u with cosine x. So this will be equal to negative natural log of cosine x plus c. And if you want, you can further simplify this. From the rules of natural logarithms, we can take this negative to the top. And so we shall have natural log of cosine x raised to the power of negative 1 plus c. And at this point, we can take this to the bottom, and the negative exponent will become positive. So this will be natural log of 1 divided by the cosine of x plus c, and that's our answer. Now let's look at what we call trigonometric substitution. Let's say you have the integral of 8 divided by 1 plus x to the power of 2 times dx. How can you solve such an integral? From trigonometry, we know that 1 plus tangent squared theta is equal to secant squared theta. So based on this, we know that we should set x to be equal to tangent theta. So we shall set x to be equal to tan theta. Now if you differentiate this, dx will be equal to the derivative of tangent theta, which is secant squared theta, times d theta. And if we come back to this, if we raise both sides to the power of 2, we shall have x to the power of 2 equaling to tangent squared theta. Therefore, we shall replace x to the power of 2 with tangent squared theta, and then replace dx with this. So this will be equal to the integral of 8 divided by 1 plus tangent squared theta times dx, which is secant squared theta d theta. And we know that 1 plus tangent squared theta equals to secant squared theta. So this will be equal to the integral of 8 divided by, instead of 1 plus tangent squared theta, we shall write secant squared theta and then times secant squared theta d theta. This will cancel with that. And so we shall have the integral of 8 d theta, which is equal to 8 times the integral of d theta. Now the integral of dx will be equal to x, so the integral of d theta will be theta. So this will be equal to 8 times theta plus c. Now from x equals to tangent theta, if we take tan inverse, we shall have theta equaling to the tan inverse of x. So we shall replace this with this. This will give us 8 times the tan inverse of x plus c, and that's our answer. So this one is called tan substitution. Now let's look at sine substitution. Let's say we have the integral of 5 divided by the square root of 1 minus x to the power of 2 dx. How can we solve such an integral? From trigonometry, we know that cosine squared theta plus sine squared theta equals to 1. And therefore 1 minus sine squared theta will be equal to cosine squared theta. And from this, we know that we should set x to be equal to sine theta. So we shall have x equaling to the sine of theta. And if we differentiate this, dx will be equal to the derivative of sine theta, which is cosine theta d theta. And coming back to this, if we raise both sides to the power of 2, we shall have x to the power of 2 equaling to sine squared theta. And so we shall replace x to the power of 2 with sine squared theta, and then replace dx with this. So this will be equal to the integral of 5 divided by the square root of 1 minus x to the power of 2, which is sine squared theta, and then times dx, which is cosine theta d theta. And so we shall have the integral of 5 divided by the square root. Now we know that 1 minus sine squared theta equals to cosine squared theta. So this will be cosine squared theta, and then times cos theta d theta. And so we shall have the integral of 5 divided by, now the square root of cosine squared theta will give us cosine theta times cosine theta d theta. This will cancel with that. And so we shall have the integral of 5 d theta. And if we integrate this, we shall have 5 theta plus c. And if you remember, we had set x to be equal to sine theta. So if we take the inverse, we shall have theta equaling to the sine inverse of x. Therefore, our answer will be 5 times the sine inverse of x plus c. Now there is also what we call integration by parts. Let's say we have the integral of x times sine x dx. In this case, you cannot use U-substitution, because if you set u to be equal to x, the derivative of x, which is 1, cannot cancel with this x. So to solve such an integral, we need to use integration by parts. And from integration by parts, the integral of u times dv is equal to uv minus the integral of v times du. And for this example, we shall set u to be equal to x. If we differentiate this, du will be equal to the derivative of x, which is 1, dx. And then we shall set dv to be equal to the sine of x times dx. If we integrate both sides, the integral of dv will be v equaling to the integral of sine x, which is negative cosine x. Now the advice I can give you, you should always set u to be equal to something that is easy to differentiate, and then set dv to be equal to something that is easy to integrate. For this example, both x and sine x are easy to differentiate and also easy to integrate, so we can use whatever we want. Therefore, our integral will be the integral of u, which is x, times dv, which is sine x dx, equaling to uv, which is x times negative cosine x, and then minus the integral of v, which is negative cosine x, and then times du, which is dx. So in simple terms, the integral of u dv is the same as this. And this will give us x times negative cosine x, which is negative x cosine x, and then a negative times a negative will give us a positive. So this will be plus integral of cosine x dx. So we shall have negative x cosine x, and then plus, when you integrate cosine x, you get sine x. So this will be sine x plus c, and that's our answer. Now you try out this. Solve the integral of x times e to the power of 5x dx. Once again, we cannot use U-substitution, so we shall use integration by parts. We shall set u to be equal to x, and if we differentiate this, the derivative of u, which is du, will be equal to the derivative of x, which is dx. And then we shall set dv to be equal to e to the power of 5x times dx. And if we integrate this, the integral of dv is v equaling to, when we integrate e to the power of 5x, we get e to the power of 5x divided by 5. And so we shall have the integral of u, which is x, times dv, which is e to the power of 5x dx, equaling to uv, which is x times e to the power of 5x divided by 5, and then minus the integral of v, which is e to the power of 5x divided by 5 times du, which is dx. And this will be equal to x times e to the power of 5x divided by 5 minus, now if we take out 1 divided by 5, we shall remain with the integral of e to the power of 5x dx. And so we shall have x times e to the power of 5x divided by 5 minus 1 divided by 5. Now if you integrate e to the power of 5x, you get e to the power of 5x divided by 5 plus c. And as you can see, e to the power of 5x divided by 5 is a common factor. So let's pull it out. This will give us e to the power of 5x divided by 5 into, for the first part we shall remain with x, and for the second part we shall remain with 1 divided by 5 plus c. And that's our answer.